Hi people, notes 5.7 are on solving quadratic trig equations. And the first question that we're given is to solve the equation sine squared x minus sine x equals 2 from 0 to 2 pi. So you can solve it as is, or we could make things easier on ourselves by using substitution here. So if I let u equals sine of x, then I can replace this sine squared x as u squared, replace the sine x as minus u, and then equals 2. And then I can get everything together on one side because this is a quadratic equation, and then I would factor. Right? That's one option that I have for solving quadratic equations. So I would have a minus 2 and a plus 1. So here, this means that u would either equal 2 or u would equal negative 1. Now, you don't have to do this substitution here. I like to do it just because it makes things a little bit simpler for me. But once I've done that, I need to substitute the sine of x back in for u right here. So I would say sine of x is equal to 2. And I would also say that sine of x is equal to negative 1. Now, just a reminder, our unit circle has a radius of 1. So right here, sine right here is 0 because that's the y value. The largest possible y value I'm ever going to reach is 1. We also know that when I draw y equals sine of x, it starts on the axis, goes up to 1, goes down to negative 1. So the highest, again, I will ever reach is 1, and the lowest I will ever reach is negative 1. My range has to be from negative 1 to 1 for sine and for cosine. But here we've got sine of x equals 2, which is impossible. This is not within the range of what sine of x is. So sine will never be bigger than 1. So that means that I don't even bother with this equation right here. Sine of x will never equal 2. So now, where will sine of x equal negative 1? I know based on my unit circle that sine of x is negative 1 down here, which is at 3 pi over 2, which means that x would have to be 3 pi over 2, and that is my only solution. Let's check this with Desmos. So here I'm going to type in y equals, and then I'm going to do sine squared x minus sine of x. And remember, I want this from 0 to 2 pi. So this right here is what we're looking for. And then I'm going to do the other side of my equation, which is 2. So I'm just going to say y equals 2. And again, from 0 to 2 pi, I don't really have to indicate that. And if you notice here, my only answer is 3 pi over 2. So just a reminder, I just did y equals this on one side and then y equals this on the other side, and then I just looked for where they would intersect. So my only solution is 3 pi over 2 for this question, okay? Okay, so for this next one that we have here, I'm going to do something very similar, except this time I'm going to let u be cosine of x. So every time I see a cosine, I'm going to replace it with a u. So this is just going to say 2u squared minus 3u plus 1 equals 0. So this right here is u squared, this is 3u, and then we just have the plus 1. Then I'm going to factor this right here. So I've got 2u and a u. And then the nice thing is I would only use 1 and 1. They both have to be negatives. So this is what I would get right here, which means that u would either be 1/2 or u would be 1. Now I can go back and replace the u with cosine x. So I can say cosine x equals 1/2 or cosine x equals 1. And then here it's from 0 to 2 pi again. Let's do the 1 first because that's nice and easy right here. Cosine will only be 1 right here at 0, but it would also be 1 if I go all the way around. It would also be 1 at 2 pi because remember again, this coordinate right here is 1, 0. So this means that x could be 0 and x could also be 2 pi. Now, for cosine of x equals 1/2, that would occur either at this angle right here, which has a coordinate of root 3 over 2 1/2, or at this angle right here, which has a coordinate of 1/2 root 3 over 2. Remember, cosine is x, so I'm going to be using this right here. So that means right here, what I would do first is I would say cosine of beta is 1/2, which means my related acute angle would be pi over 3. But cosine is positive in quadrant 1 as well as quadrant 4. So this would be pi over 3 right here is my related acute angle right here, and pi over 3 right here, which means that x would have to be pi over 3. That's one option. But my second option would have to be 2 pi minus pi over 3, which is 5 pi over 3. So these right here would be my 4 answers. And then if I were to write this in numerical order, I would have 0. This is my first value, my second value, my third value, just going from least to greatest. And then this would be my fourth value. Okay? Okay, so number 3, we want to solve for 3 sine x plus 3 cosine of 2x equals 2. This one right here is a really tricky one because if you notice, we have sine of x and cosine of x right here. And to be honest, if I can avoid solving an equation with both sine and cosine in it, it would make things so much easier for me. So let's look back at the second page of our notes. We see that we have cosine 2x in our problem, and we also have sine in our problem. So I can rewrite cosine of 2x as any of these options right here, but I think I would prefer to use this one because if I use this one, then I will only have sine of x in my equation right here. I would have sine squared, but at least it would just be sine. Since I know that cosine of 2x is equal to 1 minus 2 sine squared x, then I can just rewrite this whole entire equation as 3 sine x plus 3, and then I'm going to replace cosine 2x with 1 minus 2 sine squared x. And then I'm going to say that that's equal to 2. And then I'm going to go through and I'm going to go ahead and do my u substitution. So here I'm going to say let u equal sine x because then I only have to substitute u in for the sines. So here I'm going to say 3u plus 3 times 1 minus 2u squared is equal to 2. So let's go ahead and just do our basic algebra, distribute the 3 through. And I want to get everything all together on one side because this is quadratic. And I'd rather get everything on the right side so I can make this minus 6u squared a positive 6u squared. So here I get 0 equals. When I add the 6u squared on this side, I have a positive 6u squared. When I move the 3u over, I would get minus 3u. And then when I move the 3 over, I would subtract it. So I would get minus 1. And then I can go through and I can try to solve this by factoring. There's no GCF, and it's not a difference of perfect squares. I can't factor by grouping. It's not a trinomial. I don't want to use factor theorem. I don't want to do any of this stuff. I just want to probably see if I can factor as a trinomial. And I'm telling you right now that I wouldn't be able to because there's no way that I could get factors that would work right here. You can also check by doing the discriminant if you want to as well. So because factoring doesn't work, I would try to use the quadratic formula. So here I would say u equals 3 plus or minus the square root of b squared, which is negative 3 squared, minus 4 times 6, which is a, times negative 1, which is c, all over 2 times 6. I'm just using the quadratic formula. So here I would get u equals 3 plus or minus the square root of 33 all over 12. So here what this means is u would either be 3 plus the square root of 33 over 12, or u equals 3 minus the square root of 33 over 12. Okay, so now that I've done that, I've solved for u, I can now go back and replace the u with sine of x. So here I can say that sine of x would be equal to 3 plus the square root of 33 over 12, or sine of x equals 3 minus the square root of 33 over 12. And I want to know, are these numbers even possible? Because remember, again, sine can only be between -1 and +1. So I'm going to go to my calculator and try to figure out what these numbers are. So my first number right here, 3 plus the square root of 33 all over 12, is approximately 0.7287. So here I'm not going to use this number, but I am just going to write myself a note that this is 0.7287. This is possible. Sine of x is allowed to be 0.7287 because, again, sine of x has to be anywhere between -1 and +1. Now let's figure out what this number would be approximately. So instead of plus, I'm just going to delete this, make this a minus. I get -0.2287, which is also possible for sine, because again, sine can be anywhere between -1 and +1. So now that I've done that, both of these numbers are viable options. However, because this one is positive, sine is positive in quadrants 1 and 2. Because this one is negative, sine is negative, in quadrants 3 and 4. I'm going to bring this back up here because I'm running out of room. So we've gotten to a point where we have, again, I'm just going to copy this down. Sine of x is going to be equal to 3 plus the square root of 33 all over 12. Or sine of x is equal to 3 minus the square root of 33 over 12. And again, I'm just going to write on top right here 0.7287 and -0.2287. And then I'm also just going to write myself a note that this is for quadrants 1 and 2. And here we're looking at quadrants 3 and 4. Okay, so we need to find a related acute angle right here. So for this right here, I would say sine of beta is equal to, and I don't want to use the decimal approximation. I want to use this exact answer, so that way the less rounding I do, the more accurate I have as my answer. So that means beta would be the inverse sine of 3 plus root 33 all over 12. I can type that into my calculator. So I would go to function, I would do the inverse sine of, and then I would open up my fraction, and I would write 3 plus the square root of 33 all over 12 right here, and I would get 0.8164, so on and so forth. But if you don't have this functionality in your calculator, you can just do 3 plus the square root of 33 in your calculator, get an answer, take your answer, divide that by 12, get that answer, and then you can just go to the inverse sine of that answer, and you still get that 0.8164 that we got up here. So here we know that beta is going to be 0.8164, okay? Now, for this one's a little bit trickier, so pay really close attention to this, because this whole entire expression ends up being a negative number right here. When I want to find my related acute angle, just like we always do, like for example, don't write this down, but if I have sine of x equals -0.4, we would say sine of beta equals +0.4. We would just change the sign. Well, I would do the exact same thing here, except this is such an ugly number. So what I would do is I would say sine of beta is the -3 minus root 33 over 12, which means that beta is the inverse sine of negative and then 3 minus root 33 all over 12. Close this bracket and then close this bracket. Type that into your calculator and you would end up getting, I would do inverse sine of negative, and then I would open up a new bracket right here, and then I would say 3 minus the square root of 33 all over 12, and I would end up getting 0.2308. So I know beta is 0.2308. But if you remember right here, the answers to this are in quadrants 1 and 2 because sine is positive in quadrants 1 and 2. So that means that my first answer for x would just be 0.8164. My second answer for x would be in quadrant 2 right here with a related acute angle of 0.8164. So my second angle right here would have to be pi minus 0.8164. So my second angle is approximately, and if you noticed, I actually typed in b here for my beta, and then now I'm going to do pi minus the b because I want to get, I don't want to do any rounding until the final answer right here. So I end up getting 2.33. So my second value for x would be 2.33 radians, okay? And then this one, I'll be consistent right here. Let's actually make this value right here 0.82. Now let's go ahead and look at our next answer for beta right here. So our other related acute angle is 0.2308, but it was originally the inverse sine of a negative number, which means we're looking at quadrants 3 and 4. So this related acute angle right here is 0.2308 right here, as well as 0.2308 right here. So that means that my x3 would have to be pi plus 0.2308, and then my second angle would have to be 2 pi minus 0.2308. So then I would just type those into my calculator. But now I'm just going to change this back here into the number that we got before. And so I got 2.308, but now I want to do pi plus my angle right here, plus the b. So we get 3.37. That's my first answer. And then my second answer would be 2 pi minus beta, or 2 pi minus 0.2308, and that would be 6.05. So that means that my answers are 3.37 and 6.05. So now if I were to write my answers, all four of my answers in numerical order, they would be 0.82, 2.33, 3.37, and 6.05 radians. All right, our last example involves secant and cosecant right here. And because we're talking about secant and cosecant, we've got things in the denominators. So that means we have to first of all talk about our restrictions. So remember, secant of x is 1 over cosine of x. So our first restriction is that cosine of x cannot be 0. I can't have 0 in the denominator here. Where is cosine of x equal to 0? At pi over 2 and at 3 pi over 2. So x is not allowed to be pi over 2 or 3 pi over 2. However, right here, theta, and I'm sorry, this is a typo. This should say x right here. And also, I wanted you to cross off the one that was here. We originally had 0 to 2 pi. I want to talk about how to deal with this from negative 2 pi to 2 pi. So right here, if we're talking about from negative 2 pi to 2 pi, then if I were to go backwards, then this would be at negative pi over 2, and this would be at negative 3 pi over 2. It's the same thing, but we're just going backwards. So x cannot be any of these four angles between negative 2 pi and 2 pi. Okay? So here's my restriction, number 1. I also have cosecant of x, and cosecant of x is 1 over sine of x. So sine of x also cannot be equal to 0, which means that x cannot be equal to, where is sine of x equal to 0? At 0, at pi, and then again at 2 pi. But if I go backwards, it's also not possible at 0, at negative pi, and at negative 2 pi. So none of these answers are possible. Okay, cool. So this is restriction number 2. All right, so let's go ahead and copy this problem down and actually look at what we need to do for this. So I know that secant of x times the cosecant of x is equal to 2 times the cosecant of x. I'm going to get everything together on one side. So I get secant of x, cosecant of x, minus 2 cosecant of x is equal to 0. Okay, and then I'm going to factor. So I'm going to factor out this cosecant of x because it's in common with both of these terms here. When I factor it out of my first term, I've got secant of x. When I factor it out of the second term, I get minus 2. So then what this means right here is that either cosecant of x equals 0 or secant of x minus 2 equals 0. I'm just setting each part equal to 0. Well, cosecant of x can never be 0, because what this means is that if cosecant of x is 0, that means that sine of x is the reciprocal of 0, or 1 over 0, which is impossible. So this will give us no solution here. This is just not possible here. On the other side, I would move the 2 over and I get secant of x equals 2. And we might think, well, this isn't possible either because my number needs to be between -1 and 1. But that's only true for sine and cosine. For secant, I need to convert it into cosine of x. And because these are reciprocals of each other, I'm going to take the reciprocal of 2, which is 1/2. So here, a possible answer for cosine of x could be 1/2. So what we would need to do is take a look at our unit circle and find out what beta value would give us 1/2. And we know that the beta value that would give us cosine is as 1/2 is at pi over 3. So that means that beta is pi over 3. And because this is positive, that means that we're looking at values in quadrants 1 and 4. So right here in quadrant 1, one possible answer is pi over 3. The other answer in quadrant 4 is pi over 3. So actually, let me write this down. That one answer for x would be pi over 3. Another possible answer for x would be 2 pi minus pi over 3, which is 5 pi over 3. So here's one answer, here's another answer. However, reminder, theta or x here can be anything between -2 pi to +2 pi. So if I were to work the other way around right here, here's 0. When I work backwards, this would be negative pi over 3. So another possible answer, so we'll just circle this right here. Another possible answer for x could be negative pi over 3. And then the other answer would be still in quadrant 1. However, this is at -2 pi. So it's pi over 3 short of that value. So my last answer for x would be 2 pi minus pi over 3, but it would be the negative version of that answer. So x4 would be -5 pi over 3. So my full solution for this in numerical order from least to greatest would be -5 pi over 3, negative pi over 3, positive pi over 3, and then 5 pi over 3. Let's check. I'm going to put y equals secant x times cosecant of x in my first line, and then in my second line, I'm going to do 2 cosecant of x. So here I'm going to type in secant of x times the cosecant of x, but this is from -2 pi to +2 pi. Okay, so this is what the left side of my equation looks like. Now for the right side of my equation, I'm just going to type in 2 cosecant of x. And again, I'm going to make sure that I have that restriction here as well. And I can see that one solution is at -5 pi over 3. My next solution is at -pi over 3, just looking to see where the green and the blue intersect. Our next solution is at pi over 3, and our last solution is at 5 pi over 3. So I know I did this right, and I'm good to go. And that's it for this video. Let me know if you have any questions, and otherwise I'll see you in class. Bye.